Hello everyone, I am AS Akshara, an 8th grader from Frontline Newgen International School. Imagine you are in a room filled with mysterious symbols and locked chests. Each chest holds a treasure, but to unlock it, you need to crack the code. I'll share you a story. Once upon a time, in a faraway kingdom, there was a treasure hidden in a maze. The door was blocked with strange symbols and equations. Many adventurers tried to open it, but no one could. One day, a young mathematician named Alice arrived. She loved solving puzzles and saw the door as a challenge to solve. She realized that each symbol were like a math problem to solve. Each symbol stood for a number and equations were like rules to follow. With paper and pencil, she started working on the math. She solved one equation at a time, finding the right numbers to unlock the door. After lots of thinking and calculation, she solved the last equation. The door clicked open and she found the treasure. Alice had just used her math skill to uncover the door and find the hidden riches. Now, what if I told you solving these problems it's not so different from solving algebraic expressions? Yes, I am here to give lecture on the topic algebra. Just like Alice, we too can embark on a journey into the world of algebra. In this lecture, we will see about introduction to algebraic concepts, algebraic expression, basic algebraic operations, linear equations, quadratic equation and conclusion. First, introduction to algebraic concepts. Al-Kitab al-Mukhtasar fi Hizab al-Jabr wal-Mukabala is an Arabic title of the book named The Compendious Book on Calculation by Completion and Balancing. It was written by a Persian mathematician Al-Khwarizmi in the 9th century. Muhammad ibn Musa al-Khwarizmi is often referred to as the father of algebra. The word algebra was derived from the title of his book. Algebra is a branch of mathematics that uses symbols and letters to represent numbers and quantities in equations and formulas. It helps us understand and solve problems involving unknown variables. We'll explore the concepts of algebra through the example of finding the perimeter of square. The formula to find the perimeter of square is 4s. In this, s is a variable. A variable is a symbol which has various numerical values. It is usually denoted by x, y and z. And 4 is a constant. A constant is a symbol that has a fixed numerical value. Now we will see about algebraic expressions. These expressions contain a combination of constants and variables connected by addition, subtraction, multiplication and division, and thus they are called algebraic expressions. Factors. Factors are numbers and literals multiplied together to get the given equation. For example, 14x is the product of 14 and x. 14 and x is the factor of 14x. In this, 14 is a numerical factor while x is a literal factor. Coefficient. Any factor or group of factor of a term is the coefficient of the remaining part of the term. For example, consider the expression 9xy. In this, 9 is a numerical coefficient while x and y are literal coefficient. And the coefficient of x, that is the remaining part of x, is 9y and the coefficient of y is 9x. Like terms. Like terms are terms that have same variables raised to same powers. They can differ only in their coefficients. For example, consider the expression 3x plus 2y minus 5x plus 4y. In this, 3x and minus 5x are like terms because they both have the same variable x. Similarly, 2y and 4y are like terms because they both have the same variable y. Unlike terms. Unlike terms are terms that have different variables or same variables raised to different powers. For example, 3x square plus 2y minus 5x plus 4y. In this, 3x square and 2y are unlike terms because they both have different variables x and y. Similarly, 3x square and minus 5x are unlike terms because they both have the same variable x but are raised to different powers. Polynomials. The expression 3x minus 8 plus 4x to the power 5 contain variables whose power is whole numbers and not fractions or negative integers. Such expressions are called polynomials. Monomial. A monomial is a polynomial with one term. It can be a product of constants and variables, a constant or a variable. For example, minus 2x to the power 5. Binomial. A binomial is a polynomial with two terms. It is typically connected by addition or subtraction. For example, x square plus 5. Trinomial is a polynomial with three terms. Like binomial, it is connected by addition or subtraction. For example, 3x minus 8 plus 4x to the power 5. Polynomial. A polynomial is a more general term that can have a monomial, a binomial, a trinomial, or even more terms. Fractional powers. Algebraic expression involve variables raised to powers such as x cube, y power 4, or even z square. These powers represent the number of times a variable is multiplied by itself. In algebra, a fractional power is avoided. In the expression a to the power 1 by 2, where the fractional power is of the base a raised to the power 1 by 2, in this expression indicates taking the square root of a. In other words, if a to the power 1 by 2 denotes the number of time multiplied by itself, it gives the original value of a. If a is equal to 9, then 9 to the power 1 by 2 is equal to root 9, which is equal to 3, since 3 into 3 is 9. Negative power. Algebraic expression involve variables, constant, and mathematical operations. Inclusion of exponent is a common feature, and these exponents can be positive, negative, or even zero. When an exponent is negative, it indicates that the corresponding term is in the denominator. For example, consider the term x to the power minus 2. This is equivalent to 1 by x square. This also indicates the denominator x. This also indicates that 1 by x square and also my x to the power minus 2 is the reciprocal of x square. And here are some examples of fractional power and negative power. Constant polynomial. A constant polynomial is of the form px is equal to c, where c is equal to 0 as there are no variable terms. Linear polynomial. A linear polynomial is of the form px is equal to ax plus b. In this, a and b are constant while x is a variable, and a is not equal to 0, it has the degree 1. Quadratic polynomial. A quadratic polynomial is of the form px is equal to ax square plus bx plus c. In this, a, b and c are constant and a is not equal to 0, it has the variable, it has the degree 2. Cubic polynomial. A cubic polynomial is of the form px is equal to ax cube plus bx square plus cx plus d. In this, a, b, c and d are constant and a is not equal to 0, it has the degree of 3. Quadric polynomial. A quadric polynomial is of the form ax to the power 4 plus bx cube plus cx square plus dx plus e. In this, a, b, c, d and e are constant and a is not equal to 0, it has the degree 4. Quintic polynomial. A quintic polynomial is of the form px is equal to ax to the power 5 plus bx to the power 4 plus cx cube plus dx square plus ex plus f. In this, a, b, c, d, e and f a constant, and a is not equal to 0, it has the degree 5. Sectic polynomial. Sectic polynomial is of the form px is equal to ax to the power 6 plus bx to the power 5 plus cx to the power 4 plus dx to the power 3 plus ex square plus fx plus g. In this, a, b, c, d, e, f and g are constant and a is not equal to 0, it has the degree 6. Septic polynomial. A septic polynomial is of the form px is equal to ax to the power 7 plus bx to the power 6 plus cx to the power 5 plus dx to the power 4 plus ex to the power 3 plus fx square plus gx plus h. In this, a, b, c, d, e, f, g and h are constant and a is not equal to 0, it has the degree 7. Basic algebraic operations. Addition. In algebra, addition involves combining an expression. For example, 7x to the power 4 plus 9x to the power 4 is added to give 16x to the power 4. While adding, you will add the coefficient of the term. Subtraction. In algebra, subtraction is the process of taking away one term from another. For example, 25x to the power 9 minus 2x to the power 9 gives 23x to the power 9. In addition and subtraction, only like terms can be added and unlike terms cannot be added or subtracted because their algebraic paths are different. Multiplication. Multiplication is the product of multiplying two numbers to get the equation or the expression. For example, in the expression 3x x cube into 10x to the power 6 results in 10x to the power 9 because while multiplying you will multiply the coefficient and add the power of variables. Division. Division involves the process of dividing one term by another. For example, 225x to the power 6 divided by 15x cube gives 15x cube because you will divide the coefficient and subtract the power of variables. Division may also include long division and synthetic division while dividing a polynomial. Long division is more general term than a synthetic division. Here are the steps to solve a long division. For example, write the dividend x cube plus 2x square minus 25x minus 50 and the divisor x plus 5 in the long division format. Divide the first term of the dividend by the divisor, which gives x square. Write the result above the division bar. Multiply the entire dividend by the divisor of the step 2 and write the product below the dividend. Subtract the result from the dividend. Bring down the next term and follow the steps 2 and 3. Until you bring down all the dividend, you should follow the step 2 and 3. In this, the quotient is x square minus 3x minus 10 and the remainder will be 0. Now we'll see about linear equation. Linear equation is also known as first order degree equation in which the highest power of the variable is 1. When an equation contains one variable, it is known as linear equation with one variable. If it contains two variables, it is known as linear equation with two variables and so on. It is generally written in the form y is equal to ax plus b. It is represented using a linear graph. Real life examples of linear equation. Cost and revenue problems. Cost and revenue problems, it helps in calculating the cost and revenue of the quantities. Motion and speed problems. Describing the relation between time, speed and distance. Mixing solutions. Determining the proportion of different components in a mixture. Now we'll see about quadratic equation. A quadratic equation is a second order degree polynomial equation with single variable. It has the highest degree of 2. It is generally written in the form ax square plus bx plus c is equal to 0. And here x is a variable, a, b and c are constant with a is not equal to 0. If a is equal to 0, the equation will not be quadratic, it will be linear because anything multiplied with 0 gives 0. It is represented using parabolas. There are different types of parabolas. They are upward facing parabola. When a is greater than 0, in the standard form, x is equal to ay square plus by plus c, the parabola open upwards. The vertex is the minimum point on the graph. Downward facing parabola. When a is lesser than 0, in the standard form, x is equal to ay square plus by plus c, the parabola opens down and the vertex is the maximum point on the graph. Rightward facing parabola. In the standard form, y is equal to ax square plus bx plus c. When a is greater than 0, the parabola opens to the right. Leftward facing parabola. In the standard form, y is equal to ax square plus bx plus c. When a is lesser than 0, the parabola opens to the left. Conclusion. Pure mathematics is in its way the poetry of logical ideas. It was said by Albert Einstein. This quote beautifully compresses the idea that algebra as a branch of pure mathematics not only involves solving equations but also exploring the elegance and beauty of logical reasoning. Thank you.